So without further ado, B612 Holding Company.
Thank you very much. Thanks to all the panelists for taking the time today to listen to all our pitches. My name is Ed Liu, and I'd like to present on SpaceMap, which is a product from the B612 Holding Company. What it is a comprehensive map of the solar system, which allows users to easily calculate trajectories, calculate locations of objects in space, and share information and depict that information. So if I can have the next slide. So again, what we're trying to do is really essentially make space navigation as easy as using Google Maps is on Earth. If you think about the transformative power of what Google Maps did, it allowed, someone, my 12-year-old daughter can do manipulations on geographic information systems, locations of things, directions of the things, so on, that a trained CIA analyst was required to do in 1990. Okay, and she's 12 years old, and she in fact could do more than most of those folks could do in 1990. And it was really a matter of bringing together different data sets, bringing together things that were in different coordinate frames and making it just work, having an intuitive interface and having the computational back end just work. And that's really what the beauty of Google Maps was, Google Earth, if you'd like. So our team consists of myself. I'm a former NASA astronaut, and that's actually a former employee of Google, having worked on Google Maps. We have folks with varied backgrounds, including one of the co-founders of Applied Defense Systems, which did much of the work on space situational awareness that's being used in Space Force today. Folks from NASA or from other folks from the startup world. On the software side, our lead engineer is also out of Google. As you can see, we made use of the pipeline there. And we just recently hired a new software engineer out of Lockheed Martin. So combined amongst of us, we have many, many decades of experience at the highest levels of both the scientific side of things, the astrodynamic side of things, as well as on the computer software side, which it takes to actually build such a system. So go to the next slide. So what we really want to do is we want to make it astrodynamics, which is the calculation of trajectories again, understanding uncertainties, trajectories, where things are going, and making that as a subscription service. So where we are today is much like the geographic information systems of 1990. There are some experts around the world who, with difficulty and many, many years of training, can do these analyses. There are experts at NASA can do all of this, all right? But we're talking a few thousand people around the world, okay, that can build their own homegrown systems, none of which talk to each other. They cannot share information because everybody's system is different. Certainly doesn't scale because they build their own systems on their own, their own machines. They make use of publicly available data in many cases, meaning the locations of the objects in space, but they add their own data to it and they build homegrown systems. Okay, it's very, very difficult to build anything on top of this. In fact, what we're talking about then is to turn it into a mapping platform. Again, think Google Maps, usable by many. It's trivial to share geographic information today. I send you a link. That's it. It scales to large problems. You can handle very large, because it's native cloud application, a native cloud platform. You can do very, very large calculations, which are, as it turns out, an important part of how trajectories are analyzed today. We want to make it such that others can build off this. So it really is really a mapping platform. Go ahead, next slide, please. So what's our core technology? Well, it turns out that our astrodynamics algorithms are actually fairly well understood, and there's a number of open source astrodynamics algorithms that can do location integration, that can do orbit fitting, things like that. But what we have done is we have put them on the cloud and made them talk together, meaning we make there are literally hundreds of different coordinate systems that people use, and we've made translators that allow them all to talk to each other so that the various data sets can play well together. So I can overlay, for instance, streets on top of, for Google Maps, I can overlay it on top of maps, on top of terrain information. In the case of space, you want to overlap um, uh, celestial bodies with spacecraft with other information, but they need to all be in the same reference frames in order to do that. And we built the running on Google Cloud, we built the back end that allows all these things to run at scale so that you can call via API any of these functions. Like I want to calculate where this object will be at some point later, 3 weeks from now, for instance, or what's the range of possibilities of where it might be. So that's what our core technology is. Next slide. So who would use this right now? Well, the people, we imagine something similar in that the folks who would pay for this are the folks who generate these things, but then you would not necessarily charge people to just view them. So the kind of people who would generate trajectory information are mission designers, mission operators, folks in the scientific world, sort of that's the space and planetary science community. Turns out also that there's an important subset of this, which is how we got interested in to begin with, which is protection from asteroids. That turns out to be an incredibly interesting use case for understanding the uncertainties, because the uncertainties in the trajectories of asteroids is what leads to asteroids having certain probabilities of hitting Earth. And what people are going to do is people really want to analyze and share this trajectory information. And we want to make that easy to do. It is exactly the opposite today. It is incredibly difficult to do that and to work with other people who aren't working on your direct project. We want to change all that. So we're early on in this, and we built a working platform. So again, what's the market? Well, certainly there's a large number of new deep space missions that are being funded. We know of at least 19 of them that are funded, cislunar. There are many deep space missions, and we can essentially make their jobs much, much easier, both on the planning side as well as the mission operations side. Obviously, there are many research scientists. There are thousands of them. If you just look at for instance, the American Astronomical Society's Division of Planetary Scientists, there's thousands of folks who would use such software. So we think the near-term addressable market is in the tens of millions of dollars just for these particular use cases. In the long term, though, if the space economy does grow, and we think there's good case for that, then essentially what you're really looking at is a platform for location-based services for space. And it's a little bit different than the ground because everything's static on the ground. Everything in space needs to be four-dimensional, if you'd like. 3 spatial dimensions plus time, because everything is moving. But you can imagine that there someday will be a long-term market for such a mapping platform. And we hope that we can standardize the data formats for that. There are many that are in use, but we want to make it so that the various formats all talk to each other, in much the way that KML did for maps. Next slide, please. We've got some initial partners, which are listed here. I won't go too much further. So let me just go ahead and get to the ask. Next slide. So we are not seeking funding at this point. We are seeking help with gathering early customers for beta testing. And we'd love to get folks who could help us adapt our solution to the needs of the defense market, as we know that there are specialized use cases for this, especially as cislunar space becomes more and more important. So I'll end it there, and I'll take any questions that folks have.
Yeah, first thing that comes to my mind is this useful for collision avoidance? I mean, is this something that satellite operators might want to have either on board or running as an ongoing service to avoid space debris, you know, the growing problem?
Yeah, the issue with collision avoidance for debris is really more of a lack of data rather than it's tracking, it's shortcomings in the tracking data, not so much the depiction of the trajectories, although it could be useful for that. This is more of a deep space thing though, rather than the Earth orbit case, because the Earth orbit case there's a bunch of other factors, including atmospheric drag, that are very specific to the Earth orbit case.
So by my count, if you take the researchers out of your target market, you've only got a couple of dozen potential customers. Tell me how you're getting, and the researchers, while I see that this would be valuable, especially if they're looking at asteroids or whatever, what kind of price point are you looking at to get to that $50 million number? That seems a little high to me.
Yeah, that's a total addressable market. I'm not so it turns out that there is, what sort of sets the price is that there are software packages out there that are proprietary that people use. They're not online, they're not those things, but they're generally in the range of about $250,000. That's sort of the most popular packages is around 250,000. If you get the add-ons, maybe closer to $350,000. So that sort of sets the price point. We think we can come in well lower than that. So you don't really need that many, a couple thousand researchers gives you tens of millions of dollars. And
so is this kind of single-use license per university, or are you going to be doing software as a service, selling seat models? That's per person, $250,000 per person?
Yes, indeed. It is very expensive.
Wow. Well, that is indeed expensive. So I just
that's the need. That's and I do have to say that there is in the community, I think a universal issue with that, but they're stuck.
Yep. Okay. So and I also,
by the way, that's not our price point. That's what's out there today. Okay. So we're in the very, very early alpha test stage. So we have just gotten our first customer just right now as an alpha customer.
Okay,
so
great.
Again, I just want to set the expectation of where we are.
Well, I'm really excited to see you guys drive that price point down significantly, so all of the journalists and fanboys of the world can stop using Kerbal Space Program to do their analysis, start using something a little bit more professional. So definitely going to keep an eye on
that Kerbal isn't fun, but.
Just a couple of comments. Good to see you, Ed, as an ex-NASA person as well.
Hello, Kenny. How are you?
Pretty good. So it's regarding the cost. I noticed, since I noticed STK was a partner, you could potentially have various cost models where you could have single seats, or with this kind of partnership with STK, this could be a plugin within STK that you could have a
there's a lot of possibilities there. What we're really providing is the sort of online aspects of it. Not the doing it at scale thing, as opposed to selling them a seat license. It's maybe more of a SaaS model.
And one more thing about the onboard potential of this, because there's great potential interest in autonomous spacecraft navigation in swarms and so forth. Have you considered this? Having the star catalog that you can do onboard deep space navigation autonomously with such capability.
Yeah, while that is a definite use case for such things, this isn't likely to be the case here, because the real strength of going to the cloud is the ability to do things at scale. So it's sort of a different category of problem. Generally, when you're doing onboard stuff, you're doing very simplified things. You're really looking at guidance, navigation, control. So those tend to be quite specific to the particular spacecraft, because of that. They'll be using the characteristics of the particular spacecraft that it's flying on. Those are highly tuned.
Thank you.
Quick question. So you could go.
Go ahead.
I was going to say, quick question on my end on the product side. I've seen another company that's like exploring similar niche space in the deep space nav. They were talking about potentially taking Monty from JPL and like licensing and building the SaaS model on top of that. It's obviously limited set of partners that JPL would be willing to do that with. Have you had those initial conversations, and how difficult will it be to get that long-term partnership?
Not with JPL, but I will say that there are many other open source packages that do essentially that. So we are, for instance, using something called FindOrb for orbit determination. We are using something called OpenOrb and SDK for orbit propagations. There's a number of different things that we're using. We're not using JPL though.
Okay, Roger, for the last question.
Yeah, I was curious if you're aware of the Cislunar Highway Patrol program at the Air Force Research Labs and how your technology might be able to play and benefit that program, that effort.
Actually, not aware of it. Maybe
Okay.
In the background,
Yeah,
I'd love to hear more about it.
Okay, yep. Take a look, Cislunar Highway Patrol.
Okay, I'll write that down. Thanks.
There's a recent article that came out on it.
Okay. I know a good search engine that can find that.
Wonderful. Moving on to Radiant Technologies.